Lesson 3.6, inverse trig functions and differentiating inverse trig functions. Okay, so none of our 6 basic trig functions are one-to-one. So like in 3.5, to find the inverse, we needed like one-to-one functions. Okay, so none of them have like an actual inverse function. But if we restrict our domain, we can make them one-to-one. So they do have that inverse, okay? Usually we're only going to deal with sine, cosine, and tangent functions when we're looking at the inverse, okay? But we might see others. So for our definition of inverse functions, y is equal to arc sine, or another way you can see it written is like sine that -1, right? It means the same thing. Okay, so y equals arc sine of x, which is, right, sine y equals x. That's that inverse idea, okay? So for arc sine, our domain is from -1 to 1, and our range is from -π² to π². Okay, because right, that's where it starts becoming it's a period function, right? So it repeats. Y equals arc cosine of x is that cosine y equals x, right? And our domain is from -1 to 1. And our range is from 0 to pi. And then y equals arc tangent of x is that tangent y equals x. Its domain is from -infinity to +infinity. And our range is from -π² to π². So our first example, we're going to graph these functions. Okay, so arc sine of x, or that sine inverse x. Okay. So I'm going to have 0, 0. Right. Normally when sine is at π² is at 1, so our arc sine of 1 is going to be π², and arc sine of -1 is -π². Just kind of get this function. Okay, for cosine, normal cosine of pi is -1, so arc cosine of -1 is pi. Arc cosine at 0 is π², and arc cosine of 1 is at 0. So this looks like that. Okay, and then for our tangent, okay, right, we said its domain is all real numbers, okay, but its range is only between -π² and +π². But it can't actually be π² or -π². Okay. Then I'm going to go up here. Okay, so here's my unit circle with tangent values. So at π4, our tangent is 1. So our arc tangent at 1 is going to be π4. Okay. Also, we get at arc tangent of -1, we get that -π4. Okay. And then 0 is 0. So this function, when we graph it, it's going to kind of look something like that, okay? Where π² and -π² are their horizontal asymptotes, essentially. Okay, and we can see that, right? The bracket, or not the bracket, the parenthesis means it does not exist, or right, does not contain that. Where our brackets here, like on arc sine, do mean like that those values are included. Okay. So it says a geometric representation of the range of values for each transverse function is shown in the coordinate plane below. Okay, so right, arc sine goes between negative pi halves and positive pi halves. Arc cosine goes between 0 and pi. And then our tangent is in between negative pi halves and positive pi halves. And it says, remember that the answer to an inverse trig problem must fall in the correct range and that there is only one correct answer. Okay, so we'll see kind of some examples. Okay, so example 2, I've got sine of negative pi sixths. Okay, I'm going to go back up to my little thing here. Negative pi sixths is the same thing as our 11 pi sixths. So our sine is going to be negative 1/2. Okay. Sine of 7 pi sixths. Okay, right, that's 1 pi sixth more than sine of pi. So negative 1/2 also. Okay. Sine of 11 pi sixths is negative 1/2. Okay. But then arc sine of negative 1/2, okay, is negative pi sixths, right? 7 pi sixths and 11 pi sixths aren't in our domain, so they can't be, or not, they're not in our range for arc sine, so we can't have those values, right? Okay, let's look at another one. Okay, so arc tangent of 1, so I can go back up here, right? And we look, where is tangent 1, which is at pi fourths. Okay. So pi fourths. And then where is arc cosine negative 1? Back up to my picture up here. Okay, all right, cosine is our x value, so I look for an x value between 0 and pi. Okay. Swap colors. Right, 0 and pi. Okay, and we wanted negative 1. Okay, well, cosine is negative 1 at pi. So our answer here is pi. Okay, next, arc sine of negative 3 pi halves. So I'm going to go back up to my thing here and look for a y value of negative 3 halves. Okay, which is 5 pi thirds, or, right, because we're between, I'll write it down here, negative pi halves and positive pi halves, right? So we're going to treat this as a negative pi thirds. Okay. So negative pi thirds. Okay, and then last is for D, arc sine of 2. Okay, so back at my unit circle up here, we look for when do we have a y value of 2, and that does not happen on our unit circle. Okay. So that's undefined. Okay. And ultimately, there's not an x value when I take, you write this the right way. So there's not in our normal when I take the sine of a value that is our, that we get a value of 2. Okay. Because that's a y value. So, right, there's not an x value that equals 2. So our overall arc sine of 2 is undefined. Okay, for example 4, it says to use a calculator to evaluate. Okay, kind of depends on your calculator. Okay, but right, this is also like that sine to the negative 1, 0.3. And in this case, I get 0.305. Okay, and we need to make sure that we are in radians. Okay. Next, arc tangent of negative 5 halves gives me negative 1.190. Okay, next, simplify without a calculator. Okay, back when you're learning right triangle trigonometry and we were solving, like we wanted to find out what the angle was and stuff like that, then we would take sine to the negative 1 of things so that way it would help us cancel things out. Okay, so if I take sine of arc sine, these undo each other and I'm left with square root of 3 over 2. Okay. So then tangent of arc, tangent of 3 is 3. Arc cosine of cosine pi thirds gives me pi thirds. Okay. Arc sine of 11 pi sixths gives me 11 pi sixths. Okay. So that's how we can solve for things sometimes. Okay, next, example 6. Solve for x. We have arc sine of x squared minus 3 equals pi halves. So to solve, I'm going to take sine of both sides. Right, and right now we're just doing essentially trigonometry. We haven't used calculus yet. Okay, so I take sine of both sides. So sine of arc sine of x squared minus 3 is going to give me x squared minus 3. Okay, sine of pi halves gives me 1. So I have x squared minus 3 equals 1. I'm going to add 3 to both sides of my equation. So I get x squared equals 4. Now that I have x squared equals a number, we can take the square root of both sides. Okay. So we get x is equal to plus or minus 2. Okay, let's go look at some more examples. Okay, example 7 and 8. Sketch a right triangle and evaluate without a calculator. So we're given that x is equal to arc cosine of 2 over a square root of 5, and we want to find tangent of x. So I'm going to draw my triangle. Okay. Here's my x angle. Okay. I'm going to call this x. Right? So arc cosine 2/5. Remember, cosine of an angle equals adjacent over the hypotenuse. So that tells me that the square root of 5 is my hypotenuse. Okay, and that the 2 is my adjacent side. So tangent, which is what we're trying to find, is opposite over adjacent. So I need to find that opposite side. Okay. So to do that, we're going to use our Pythagorean theorem. So 2 squared plus, call this y, y squared equals the square root of 5 squared. Simplify my squares, so I get 4 plus y squared equals 5. Subtract 4 from both sides, so y squared equals 1. Okay. So then, tangent of x is equal to opposite over adjacent. So we get 1/2. Okay, let's look at another. So this one says, given that y equals arc sine of x, find cosine of y. Draw my triangle in here. Okay. Sine is our opposite over the hypotenuse. Okay, so we have x, so that's like x over 1. So opposite, I'm going to label that x. Actually, I'm going to change that. So opposite over hypotenuse. Okay, but we want to find cosine, right, which is adjacent over the hypotenuse. So I need to use the Pythagorean theorem to find out that side right there. So 1 squared is equal to x squared plus y squared. Okay, call that right. So then start simplifying. 1 squared is 1, so I'm going to simplify that. Right, x squared is still x squared, y squared is still y squared. So subtract x squared from both sides. 1 minus x squared is equal to y squared. Then I square root both sides, so 1 minus x squared is underneath the radical. I get y. So this side over here, let's color code it, okay, is this square root of 1 minus x squared. Okay. So now we're finding our cosine of y. Cosine of y equals my adjacent side, 1 minus x squared, over the hypotenuse. So I'm going to simplify. I get cosine of y equals 1, or the square root of 1 minus x squared. Okay. Okay. Now, example 9, use your work from example 8 to find the derivative of arc sine of x. So I'm going to write it like this. Y is equal to arc sine of x, right? I want to get x all by itself. So I'm going to apply sine to both sides of this. So sine of y equals sine of arc sine of x. So sine of y is equal to x. Okay. Now I'm going to take my derivative. Okay. So the derivative of sine, right, is cosine. I've got my y in there, so y, got to implicitly differentiate, so y prime. Actually, I'm going to write dy dx. So dy dx is equal the derivative of x, maybe, or not. Set it into the this. Okay, so the derivative of x is 1. So I've got cosine of y times dy dx equals 1. So now I'm going to simplify and divide both sides by cosine y. So I get dy dx is equal to 1 over cosine of y. Okay. But from up here in problem number 8, we said that cosine of y was the square root of 1 minus x squared. So dy dx is equal to 1 over the square root of 1 minus x squared. Okay, I'm just going to color that cosine of y, right? And color up there. So we can see how those are connected. So the derivative of arc sine of x is equal to 1 over 1 minus x squared. Okay, and we can see in this table, we've got the derivative of arc sine, the derivative of arc cosine, which is negative 1 over the square root of 1 minus x squared. We've got the derivative of arc tangent of x, which is x over 1 plus x. Okay, we also have it using our chain rules here, right, with our u's. Right, where that u is a function of x. Okay, I'm also going to add some here that you're going to want to add to your notes also, okay? So d dx of arc cosecant, okay, of u is equal to negative u prime over u square root of u squared minus 1. Okay, d dx of arc secant of u is equal to u prime over u square root u squared minus 1. Okay. And then last, d dx of arc cotangent of u is equal to negative u prime over 1 plus u squared. Okay, so those may come in handy down the road. Okay, so let's look at example 10. G of y equals arc tangent of 2y minus 1. So we want to differentiate, right? Take the derivative. So g prime of y is equal. Okay, so that's back up here, right? So we've got a u here. So arc tangent of u is u prime over 1 plus u squared. Okay. So that's my u. So my u prime is going to be a 2. So it's u prime over 1 plus u squared. Okay. Let's look at our next one. F of x equals arc sine of the square root of x. Okay, this one, once again, we have that u here, right? So u is equal to the square root of x, or I can rewrite it as x to the 1/2 to help us, right? So the derivative of u is going to be 1/2 x to the negative 1/2. Okay, so now I'm going to take my derivative. The derivative of arc sine of u is going to be u prime, okay, over the square root of 1 minus u squared. Okay. And I can simplify this, right? 1/2 x to the 1/2, that is going to pop into the denominator. And then the square root of 1 minus the square root of x squared, right? those are going to change into 1 minus x. Okay, I'm just kind of color coding stuff so you can see what kind of things start showing up. Okay, next one. Each of t of arc, cosine, or cosine inverse of the natural log of t. So that natural log of t, that's our u. So our u prime is 1 over t. So take the derivative of arc cosine or cosine inverse. And that's negative u prime over the square root of 1 minus u squared. Okay, but this looks a little wonky with that 1 over t all over everything, so we're going to rewrite it. Negative 1 over t times the square root of 1 minus 2 natural log t. Okay, right, that we have that natural log property where I can drop that power out front. Color. Okay, so ultimately you are going to want to memorize these derivatives of our inverse trig functions. Okay, right, sine and cosine are almost identical except for that negative in front of our arc cosine. Okay, tangent does not have a square root. Okay, and then kind of arc cosecant, arc secant. Okay, kind of see their little kind of differences, but they do still follow that ultimately if it has the like cosine, cosecant, cotangent, their derivatives are negative, just like when we worked with our original trig functions. Okay, good luck.